Session is being recorded. And again, the session is being recorded. Please be mindful and respectful of the class environment and your fellow students. Anything you say, type, draw will forever be recorded with your name attached to it. Okay, so please remember to conduct yourself in a professional and respectful manner. All right, so before I get started, I'm going to I'm going to change the settings for this. I'm going to allow the audio. So if you want to ask a question, you can unmute yourself. So session settings, I'll allow audio. So that's good to go. And the drawing now is the base plan, MED base. Okay, so I marked the assignments. I'm going to send out an email with the breakdown of the grade. It was done very well. Most of you at least completed everything. There were a few common, not mistakes, but common things that were maybe missed or not addressed just because of the nature of this particular project. It's a little more complex, and a couple of things that you have to be mindful of. So I want to cover some of those now. A common mistake, like I said, when you create this information, you do one part of the design, and then you add the next part, and you add the next part, and so on. And as you add more and more details, you'll find you may have to revisit something that you did before. And one of the first things we looked at was these driveways. Remember, the driveway for number 6, if you put it on the high side, if you put the driveway for number 6 on the high side, it'll end up crossing the driveway for number 5. So then we made a decision to change the driveway. Let me throw that to the back so you can see all the servicing. So we made a decision to put the driveway for lot 6 on the low side, not the high side, so that the driveways don't cross each other in the boulevard. Okay, so that's an exception to the rule. It's not wrong, but certainly something that we had to think about on the fly to make sure that we had everything that we needed so that everything works. Okay, so that was one thing we need to look at. A common mistake here when it comes to the sanitary servicing, okay, when it comes to block 56, you may have done this. Let me redo this. And there's a couple of issues here you want to be mindful of. So when I'm servicing block 56, if I make a copy of your typical dual on the common lot line, right, and I put it, and then we never service on the block line. It's always the interior lot lines. So we go 1, 2, 3, right? So I've serviced, and if you look at the service connection, right, the service connection versus the pipe, we have a connection, we have a connection, we have a connection, it all works out fine. But if you take a look, you'll find this service connection for these 2 units here actually goes right through the storm sewer. You can't have that, right? You can't put a pipe through another structure. Certainly you can't put a pipe into a structure of a different system, right? You can't, you got to be able to access the maintenance hole. So the last thing you want to do is open up the maintenance hole, try and climb down, and there's this other service pipe through the structure. It doesn't make any sense. So if you did that, and you didn't think about it, I'm pointing it out. So some of you did that. Another common mistake was here, perpendicular to the water main. And when you draw that service connection, it's in the structure as well. So then you have a choice of either moving it to this side a little bit, to the outside. That works, that's fine, but now you're getting close to the sanitary maintenance hole. So I chose my design. This is not wrong, but I think a better solution would be to go around the structure on this side. Okay, so the typical from the location of the curb stop perpendicular to the pipe will put you right in the structure. Okay, so that's not going to work. So you either have to move it out to this side or around to the other side. So these were 2 common things that a lot of people missed, and I took a mark off. Now, some people might say, well, I got everything else right, and now you're picking on this one unusual thing. Yeah, well, the everything else right, what happens between intersections and what happens between the elbows and elbow and elbow and intersection is very typical. So if you just follow the rules along those stretches of the road, usually there's no issue. Okay, so there's no extra thought or no unusual thing to be looking at. Okay, the valve chamber needs to be the same size as the manholes. I'll get to that in a moment, Stephen. Okay, so you know, what happens along the typical stretch, you still have to pay attention to some of the details. Like, where did you put these two maintenance holes? Some of you had a pipe that stretched from this intersection all the way to here. It was too long. You actually need a pair of maintenance holes here. If you measure the distance from here to here, you'll notice it's more than 110 meters. So you do need a pair of maintenance holes here and a pair of maintenance holes here for the same reason. Look, I made a mistake here too. The water service goes right through the maintenance hole. That's no good, right? So you want to move it out of the way, right? So remember, I laid out the pipe first, and then when I put in the service connection, I had a conflict, so I'm going to make an adjustment. So this is what I mean by as you add details, as you add detail to the design, the new thing, the latest thing you're working on may be in conflict with an old thing. Okay, so that's a problem. Okay? Now I moved this maintenance hole. Let's make sure this isn't too long now. That's still good, less than 110 meters. So you're always checking, making sure things aren't, you know, going to conflict with each other, right? So as you proceed, you may have to revisit a previous step. And that's just the nature of the business. As you add the detail, you might find that there might be some issues that you have to look at. Okay, so this was a common one here. So the solution I used, I left the driveways paired. So on the surface, they all look the same. But underground, what I did is I moved the service connections, the doubles, I moved the doubles over so that these two units and these two units have a common point. And then what I did here is I offset the 2.5 typical off to the side, and I had a single connection under the driveway on this side, and I did the same here. Perpendicular to the pipe, whoops, perpendicular to the pipe, offset 2.5, put it on the correct layer. So I have a single service connection here and a single service connection here for sanitary. Let me turn off some layers so it's obvious. Right? So I have a dual, and then two singles, one at each end. Okay. So I left the driveways paired, but I offset where I put my typical shared connection. I put them on these lot lines between the driveways instead of on the driveway. Okay, so now I have two singles. And then you might say, okay, you got to label those. Yeah, but I did this once before. On this block 53, there is an odd number of lots. So I did have to have one single service connection. I labeled it 250 typical. So anytime you see a single on a townhouse, you know it's 250. So I don't have to label this one and this one. And that's what the typical does for you. The other thing I did then is stretch the pipe into the lot the same amount as the tails that you see here. Just going to extend this, extend to this location, the single service and the single service. So it protrudes into the lot the same amount as this. Okay, so it's consistent looking. So this was a common error, right? The dual here going through the storm, don't do that. And the water service going into the chamber, don't do that either. Okay. A choice, I didn't take any marks off. The valve chambers for this location and for this location, you had a choice of the Regional Halton Standard 400-01 or 400-02. Could have been the rectangular or the circular one. Either one would have worked for the pipe sizes. Remember, all our pipe sizes are 200s. Why am I using the round one? Because in a similar situation, the other design was done on a 200 by 200 T, used the round one, and I'll show you where that is. So you had to do a little bit of searching in here, and I believe it's over here. Okay, so this water main is a 200. This water main is a 150. Okay, so I'm looking for the 200. I think it was up here somewhere. Here, yeah, 200. And then it's connecting to this water main here, and it's also a 200. Okay? If that label's not clear, you can see here 200. So this location here is a 200 by 200 T, and they used the round one for that one. So to be consistent, I did the same thing. So the rectangular one is not wrong. So if you use that one, I didn't take any marks off. You had to put something, one or the other. This would be the preferred solution because the 200 by 200 T is exactly what we're dealing with. Okay, so that was another, not an error in any way, just a judgment call you had to make. This would be the preferred solution to be consistent. All right. A couple of other things. So I used the round one here and the round one here. I didn't put my labels, but you had to have labels on this. Another thing here, this pipe had to connect to this pipe at 90 degrees. I wasn't going to use joint deflection on a T. I want this to be nice and clean. So this line versus this line is exactly 90 degrees so that I can use this T. So what I did was I took this alignment, right, the standard position, and I bent the pipe using joint deflection. And I used a radius, and this radius, the distance from the center of this line to a near point on this arc, I'm using a 200-meter radius, okay? Bigger than the recommended minimum. Why? Because I don't want to use a joint deflection of 3%. I want to use a joint deflection of 2%, okay? So why am I using 200? Well, if we go back to the manufacturer's guide for the pipe, which is where is it? The manufacturer's pressure pipe. If you look here, you'll see the joint deflection, which is this one. We have a 200 millimeter pipe. So if you do a 3% joint deflection, you can mimic a 116 meter radius. So I just doubled it basically, 200, so that should work. Okay, so then I don't have to buy a 90, a 45, a 22 and a half, or a 14 and a half, a 14 and a quarter elbow. So I don't have to buy an additional piece. I can just kink the pipe along and it should work. Okay, so that's how I achieved. And again, a lot of people were asking me about this, and all I said was, when this pipe meets this pipe, make sure in here it's exactly 90 degrees. So that's what I did. Okay. Another common issue was if this is your last service connection, there's no reason why your sanitary pipe and maintenance hole should be all the way out here, right? Between this point and this maintenance hole, this pipe is empty. There's nothing connected to it. So why waste all that pipe? So bring it in as close as possible. Okay? I had it closer, but then I had this water service connection coming through, so I pushed it back a little bit more. This one here, we still don't know. We won't know where to put this one until we design the road profiles and put in all the low points on the road. Okay, so that was another issue. So this one here, as long as you had a maintenance hole out here somewhere, you could have left it close to the intersection or not. The final position of this will be determined later. Raymond, there's two techniques, right? There's two techniques. Carl, this is your answer. If I want to go around a curve, if the road is curved and I offset the curve, then we can, there's two techniques. We talked about this, okay? There's two techniques. I can deflect the joint, right, and have a series of chords that mimics a curve, right? And I'll show you what that looks like in the CAD file, right? So most pipes are about 6 meters long. So if I have a line 6 meters, right, there's a pipe, okay? I'm going to make a copy of that and join it, right? So when you're going in a straight line, at every point where the pipe connects to the next segment of pipe, I can deflect it. I can deflect it. The manufacturer says 3 degrees. I'm only going to use 2 degrees. I don't want to push the limit, right? So then I take the next pipes, not that one, but the next one, and I rotate 2 degrees. And then I take this and I rotate 2 degrees, and I take the remaining pipes and I rotate 2 degrees, and I take the remaining pipe and I rotate 2 degrees. So at a glance, it looks like a curve, but really it's a bunch of straight lines where the deflection angle at each joint is 2 degrees. So it looks like a curve, right? And if you draw that arc, if you draw an arc or a circle with 3 points, and if I snap from here to here to here, it looks like a curve. And what's the radius of this curve? It's about 171 degrees. So anything bigger, I can kink less than 2 degrees, and I can approximate a curve without buying a bend. Okay, so that's allowed. Another thing you can do, which is not allowed, so we can deflect pipes. Yeah, but instead of drawing it as a segment, a bunch of straight lines, I just put in an equal radius that'll work. Okay, and nobody's going to see the details of that. So what I drew here is an actual arc, because I know they can achieve that radius by the method of joint deflection. Oops. Does that answer your question, Carl, Raymond? Okay, so I know the construction technique, but schematically I'm still showing it as if it's a radius. and then the contractor will do what they have to do to make that happen. Okay, remember, as a designer, you're not allowed to tell the contractor how to do their work. You can only show them a picture of when they're done their work, this is what I need to have. So this is really schematic. Okay, so this could be a radius. Okay, as long as the radius can be achieved based on the construction method of joint deflection. The other thing you can do, which is not allowed, instead of deflecting at each joint, every time you make a connection, you kink it by 3 degrees or 2 degrees. You can actually bend the pipe, physically bend it, right? But that puts undue pressure on the pipe, and the region doesn't allow that. So this method, even though the manufacturer says you can do it, the region doesn't allow it. So we can't use that technique. Okay, does that satisfy you guys? Carl, Raymond, does that make sense? I hope. Okay, I use the same technique over here. Some people use the joint here. I use a radius. There's a radius right here. So I took this alignment from here to here, which is in the typical position, parallel to the street line, right? So if you offset, I think it's, if you offset, right, you offset 5.3, you get the actual position of the standard pipe, okay? And then I took that and I took this alignment. So I filleted this with this straight line here. Let me explode it. This line versus this line, and I used a fillet radius. I used a fillet radius right here. And the fillet radius, again, for the same size pipe, I used a 200 meter, right? So I kinked the pipe so that it bends and aligned up. This and this have the same bearing, right? This is just an extension of this direction, right? So I bent the pipe using joint deflection with a big enough radius that I know that the contractor can achieve by joint deflection so that it connects to the pipe. Okay, and that's the more elegant solution. If you wanted to, you could measure the angle between these two, right? This is the deflection angle, 3 degrees, right? To get a 3 degrees bend, there's no such thing. So anybody who used an elbow of 11, a quarter, 22 and a half, 45 degrees, it's not going to work. Okay, but see, it says 3 degrees, 3 degrees. You could do the joint deflection, right, with 2 degrees, right? So I wouldn't push it. Again, the manufacturer's guide says you can push this to, where is it? You can push this to 3 degrees, okay? But the municipality says you can only do 70% of that, which is roughly 2 degrees. So the method here really is this bearing and this bearing are so close to each other that the best solution is to bend the pipe using joint deflection and not by any kind of fixture, a 22 and a half, 11 and a quarter, and so on. Okay, it's so close to straight that we can just bend the pipe using joint deflection. So anybody that used an elbow of any kind here, it's not going to work. I didn't take marks off. Okay, as long as you made the connection, you did something, right? The plumbing works, but it's not practical. Okay, even the smallest bend, 11 and a half, is going to bend the pipe too much, and you're going to miss connecting. Okay, so the best solution here is to fillet between the standard position and the existing position with a radius of at least 170. That's why I used 200, and we were able to achieve that. Okay, and again, I drew a radius. I didn't draw the kinked pipes with the 3 degrees or the 2 degrees bends, right? So that's how I made my connection here. Okay, the water main connection in the corners and up here is all 245s, even if it's not exactly 90. That's close enough. Here you can do joint deflection on the fixtures to achieve the change in direction. Okay, sanitary sewer and storm sewer. This is my solution. Okay, as long as you did something, I gave marks. Okay, let's look at the solution for a second. Let's just get rid of some of the noise here. Okay, this is the standard position of the storm and the sanitary pipe. How am I going to connect to the existing storm and sanitary? And the advice I gave here was make sure that you, from the edge of pavement, come in about 3 meters. So these pipes should be undisturbed beyond this point. So everything to the right of this highlighted line should be undisturbed. So I put a maintenance hole exactly there, and then I brought it in and I connected it to here. Okay, and then I made these two parallel. Right? If I take one and put it on top of the other, they're actually parallel. Some order of standard, right? So you'd like the pipes to be parallel. So I drew this one first from this position to somewhere on this pipe. And then I made a copy of this, right? And I offset it by 2 meters, right? Standard position, right? Typical 2-meter layout. And then I found this intersection and this intersection. And you can see they're both outside the zone. Do you need to be further away from the edge of pavement for storm? No, not really, because what happens in the cross section, that's a good question. What happens in the cross section is the pavement looks like this. And then 3 meters away, say 3 meters away, we look like this. The storm sewer is here. And when we put in the maintenance hole at this 3-meter position, you're going to get a connection, a connection that looks like this, approximately. And you can dig down. This would be the line of influence, right? 1 to 1 or 1 to 2, so that you can get down to this depth. And that's why you want to maintain. You don't want to put the maintenance hole right on the edge of pavement. Otherwise, when you go to dig straight down, if you dig straight down, then this pavement's going to fall apart. So 3 meters is typical, right? If you stay away by at least 3 meters, then you should be able to uncover this pipe, connect to it, put a structure in, and still have a stable slope to hold up the original road. Okay. Now 3 meters is a number that works for nominal depth. If you have unusually deep pipes, like if this is way down here, then you need to move this a lot further away so that this slope that holds up the pavement is going to be, you know, the toe of the slope is far enough away. So that's really what I'm basing it on. But on a typical depth sewer, 3 meters will do. 3 meters from the edge of pavement across should do. Okay. So it's a rule of thumb, but you have to look at the nominal depth. How do I know what the nominal depth is? Well, I go to Ledger Way. This is why you're always looking at the information, right? So our connection is roughly here. So if I look here, you'll see the storm sewer, you know, is a typical depth. If this is 1.7, this is not much deeper, right? 1.7 to the top of the water main, the storm sewer is not much deeper than that. Right? The sanitary sewer is way down there, but not the storm sewer. Okay, so the sanitary sewer wants to be further away. Okay, and then you'll see in the CAD file, the sanitary sewer is further away than this one, right? It's close, it's tight, but certainly you want to make sure that you keep away from the edge of pavement. So that's one solution. Now, is this the solution that's going to work? There's other things to look at now, okay? Remember, we're going to have a low point. Remember these 2 points here? If I draw a line from here, perpendicular to center, and I draw a line from here, perpendicular to center, which one's further away from the intersection? This one. So if I extend it across the road, that's where my catch basin is going to be. That's where my catch basin is going to be. This is where my low point on the profile is going to be. Can I put in 2 catch basins and make all this plumbing work? Okay, well, so I drew a solution for that. So here's mine. Just moved it over for the sake of the discussion. 500. So I can put in a catch basin and connect perpendicular to the pipe, and I can put in a catch basin and connect. It doesn't have to be perpendicular. Okay, I could use something different here. We'll talk about the details of that later, but I can make this connection. So the structure physically fits. It's tight, but it fits. Okay. If it was too tight, some of you used a pipe that went across here. It's connected all the way back here. Well, now you're not going to be able to fit the catch basin in. Okay. So why did I put my pipe here and here? Because I'm thinking ahead. When my catch basin goes in, am I going to have room for it in this space? Right. So that's something to think about. Some people put a pipe from the center of the existing maintenance hole all the way to this one. That's not wrong. But now the structure is in conflict with where you want to put your catch basin. So that's not a very good solution either. Okay. So again, whatever you did here, you didn't have the experience or the information from me thinking forward. Are the catch basins going to fit? Okay. I did talk about where the low point was going to be, but what does that mean to the hardware requirements? We're going to need catch basins at either end. So it is a little bit tight. If it's too close, if you think this is too close to this, then you can always rotate this and this about this center. All right, you could always rotate the system this way. This pipe now got further away from the structure, and then you could just determine, okay, I'll put the maintenance hole here, and I'll put the maintenance hole here, and have this connection. All right, I can do this with my storm sewer, and I can do this with my sanitary sewer. Sanitary sewer here and here. Okay, so then I can connect this to the actual structure. I'm not sure if that's allowed. That's one way of doing it. Or you could just service the catch basin off the side, the midpoint here, and connect downstream of the maintenance hole that way. So that's another connection you can make. But now these two structures might be too close together, and so on. So these are the little kind of determinations you need to figure, right? I don't like the two structures that close together. I think the pipes, this solution works fine. Okay, and then you clear the structure here, and everything seems to work. So this is kind of my preferred solution. Now, again, there's more than one solution, right? But certainly you have to be careful. Now, if it really gets tight in here and you can't find a solution without disturbing these two pipes, then you may consider digging up the original road and realign the pipe so that you get a connection that makes sense. Okay? But if you do that, you have to rip up the entire road to the maintenance hole, and that's what I'm trying to avoid. Okay? Some solutions are going to be more elegant, more cost-effective than others. But again, this is the kind of thing you're going to have to make a determination on. If you're the lead designer, you have to propose something. If you've been asked in this, like I asked you, without a lot of experience or information, think about your first job when you leave Seneca. If you're not sure how to do this, again, I've said this before, propose something, right? Make sure that you have a solution, something you think will work, and then go and discuss it with a senior designer and say, hey, I got to make this connection. Here's what I think. Got any better ideas? And maybe their experience will give you a better suggestion. Okay. And if the designer has your best interest at heart, they won't tell you what to do. They'll just make suggestions. And at the end of the day, you're the designer. You need to make a decision. Okay, I'm going to do this. Ultimately, the municipality has to review it and decide whether it makes sense or whether it's something that they like or don't like. Okay. So ultimately, whoever approves it, whether it's your boss or finally the agency that's accepting the design, they'll tell you whether they really like it or not, okay? But at the end of the day, you can't go to them and say, okay, how do I do this? You have to suggest something before you start the conversation on how can I improve this? Does this make sense? Well, what would you do differently? These are the kinds of questions you want to have. So the discussion starts with some kind of proposed solution. Don't ever go and ask for help without trying something first. Okay? That's the best advice I think I can give you before you graduate, because it's just going to make you look bad. Okay? You have to have some idea of how you think it should proceed. Okay? I know I'm lecturing a little bit, but it's an important point. And then you'll gain a lot more respect from the people you work with and the people that are training you. All right? Any questions about that? Okay? A couple of students made the mistake. I mentioned it in class. There should be between this elbow and this elbow, no sanitary or storm. The sanitary and storm ends on street A here, approximately, and the sanitary and the storm ends someplace over here. And there is no sanitary or storm sewer going to be required here. Certainly sanitary, there's no houses fronting onto this street, so the sanitary is not necessary. The storm sewer may or may not have to go around the intersection or the bend here. Right? And I'm pretty sure you won't need it, and we won't know that until we design the profiles, which is what we're going to discuss today when we get on with the design. Okay? So I just wanted to point out a few common issues that students were dealing with. Okay, so let me just turn on a few more layers here. All right, the other thing is there's no sidewalk required here. Okay, and I'm going under this assumption. Any of the roads, any road, the window road, you know, the roads that have only houses on one side and then are adjacent to the road exterior to the site, any of those connections in the elbows has the sanitary go outside the subdivision at this point here and connect to this existing 3-meter wide side. So instead of, if you're walking in this subdivision, you're going to walk along the sidewalk, go outside to the other road and walk up this sidewalk here. And then you can come back into the subdivision here. There's a sidewalk here. There may or may not be a fence here. So if somebody walks along the sidewalk and wants to come to this house here, then they could cross the road. Okay? There may or may not be a fence there. I don't think there's a fence there, or it would be on this drawing. Okay? But there's the connection point across here. So there is no sidewalk on either side of the window road, the road adjacent to the existing road on the outside of the site. So there should be no sidewalk. You'll see here, right? There's no sidewalk on this. There's no sidewalk on this boulevard. There's no sidewalk on this boulevard. The sidewalks go across and connect to this outside sidewalk. Okay, so we had a sidewalk on both sides. So one connects here, right? And I only told you to take it to the edge of the subdivision. And then the sidewalk on this side comes across to the edge of the site. So you need a piece here, and then across here, one across here, and then this one goes straight across to here. So there should be 4 connection points according to how many sidewalks I told you to produce. It looks like this. Right? So you have a sidewalk on both sides, extend it across, and trim it between the back of curb on both sides. That's where the sidewalk ends and starts again. Right? So this one goes across, this one goes here, is interrupted by the curb lines, and then goes to there. And the same thing here. Here, go across, here, go across, and there's no sidewalk on this piece, and there's no sidewalk on this piece, okay? A lot of you had sidewalk along there, and some of you had a sidewalk just on this side. I don't know where that was coming from, but this is what I asked you to do in class, okay? Now going forward, if you review this subdivision, you'll notice they only have sidewalk on one side. Right? If you look at any road, there's only sidewalk on one side. Right? There's a sidewalk on this side, no sidewalk on the opposite side of the street. Okay? Only one side. Can anybody tell, or did anybody figure out, right, which side of the road the sidewalk is on? Is there anything common that you can figure out that tells you, if you're going to have one sidewalk, which side of the road did they put the sidewalk on? Did anybody review that or notice a pattern? No, not close to the sanitary. Samuel, you've got it. It's on the side of the road that has the hydrants, or more specifically, it's on the same side of the road as the sidewalk. So you'll notice here, right? The water main is on this side of the road, so is the sidewalk. Let's look at this road. The water main is on the side, right? There's the water main, right here. There's the water main. Sidewalks on the same side of center, and the hydrants are on that side as well. Look at any road, and you'll see wherever the water main is, that's the same side of center that the sidewalk is on, right? Look here, there's the water main, sidewalks on that side of the road, right? Remember, the sanitary sewer is in the middle. Water main, sidewalk on the same side. Look at any road in this subdivision, that's always true. Water main, sidewalk on the same side. Okay? So if we were to follow that kind of guide, okay, again here, notice the sidewalk, the water main is on the north side, it's on the west side, it's on the south side, right? Always, if you look at it, it's always, if chainage is increasing in this direction, it's always on the right side of center, so the sidewalk is on the right side, all the way around. So if we were to follow that same guide, then I would remove, there's my water main, there's my sidewalks. I would remove the sidewalk on the opposite side of the water main. I would get rid of this sidewalk, and I would get rid of this sidewalk. Right? So now the sidewalk is on this, whoops, the sidewalk, wrong one. The sidewalk is on the same side of center. Sorry, this one. This goes away, and this one goes away. So that's the sidewalk solution. Then you got to clean up the intersections a little bit. Right? Then this is no longer true. Just take it across to the back of curb. That still works. No sidewalk on the north side here, because the water main's on the south side, and no sidewalk on this side, the north side, and no sidewalk on the east side. The sidewalk is on the water main side of the road. Okay, but you still need this to connect to the edge of the subdivision, so you can connect to that sidewalk outside, and you still need this little piece here to extend across the road, so that when you cross from here over the pavement to here, you can connect to the sidewalk outside the subdivision. When you do that now, you need to re-hatch your driveways, right? So all of these on the north side, all of these need to be rehatched, and all of these need to be rehatched, because there's no sidewalk there anymore. Okay? I'm not going to do that now, but you need to do that. There's no sidewalk there, so we need to get rid of these little pieces, extend from the back of curb to the boulevard, and hatch the sidewalk right through. Put it on the correct layer. All right, so there's your side. It's not interrupted. Okay, so I'm going to leave that up to you. So you do have to do this. So for the next submission, the sidewalk is on the water main side of the road, that boulevard only. Get rid of the other one and make the adjustments. So there's some rehatching to do on the driveway and the removal of the sidewalk and a little bit of tidying it up maybe at the intersections. Okay. Another issue here, I didn't take marks off for this. How do you lay out the sidewalk in the elbow? Okay, and I want you to look at this. It's very subtle. If I offset from the back of curb, right? If I have from here perpendicular to the edge of the sidewalk, if I offset the back of curb, the sidewalk is there, and then 1.5, the sidewalk is there. So is the sidewalk here so that it has a constant offset from the back of curb? Or is the sidewalk here where the sidewalk has a constant offset from the right-of-way line? Remember the 0.3 meters between these two? Either way, either solution, you could put the sidewalk here and have a constant boulevard width, right? Back of curb to sidewalk will be constant around the curve. Or you can put the sidewalk here, which is always parallel to the street line, okay? Either one would work. It's in the boulevard, it really doesn't matter. What I drew, 0.3 meters off of this, is more in tune with the standard. What am I talking about? Let's go back to the standard, okay? And these are the lessons you need to learn that, you know, neither of them is wrong, but one makes more sense than the other. Why? Because when you look at E2, the layout of the sidewalk, you could have a constant boulevard width of 1.7, or you could have a constant offset from the right-of-way. So which one do you choose? Do you use 1.7 or do you use 0.3? And remember, the boulevard width, this dimension, right, from the back of curb to the street line, gets wider as you go around the bend. Remember, it gets wider. It's an elbow. So you have to make a decision as a designer. Should I put it so that we have this numbers constant all the time and this thing gets fatter? Or do I keep this relationship and then use this getting wider to go around these curves? And that's the decision you need to make as a designer. Okay. The preferred solution, there really isn't one because you have two dimensions, right? One of them is going to be upset, right? If I offset this dimension, right, distance from here perpendicular to here, if I offset by this much, from here perpendicular to here, right, that's the 1.7. But if I offset from here, I have 0.3, right? So you have to make a decision. I would choose either this solution or this solution. So when you look at the standard, I would respect, one of them has to give, right? So I would use this number or this number. Make a decision. You have to decide what it's going to be. Should you make the boulevard wider or should you make the offset wider, right? You need to make a decision. I prefer being parallel to the street line. And the reason I do that is then it's easier to relate the drive, it's easier to relate the edge of the sidewalk as a monument on the ground to the property line. It's always the same relationship. Okay? It's not wrong to do this. It's not wrong to do this. It's either one or the other. Okay? I wouldn't certainly vary both dimensions, right? I wouldn't put it somewhere between, but I would make it either parallel to this line or parallel to this line. And make a decision. I wouldn't make the sidewalk vary. You want the sidewalk to be a constant width of 1.5. Okay, so this is my preferred solution. So you could do it either way, but then if you came to me for advice, I would say, please do it this way. And sometimes the only reason you're going to get from me is because I said so. Okay, now, what did the other designer do? Let's go back to the subdivision. There's always a hint here, right? And you'll see when you go around the bends, they kept it parallel to the property line and they made the boulevard wider here. So this dimension got wider here. So they did exactly what I'm suggesting you do. Okay, so all the elbows are like that. There might be a better example here. Now you can see this boulevard is wider, right? The sidewalk's on the other side. That's a bad example. Hang on. Here's a better example. Here. Yeah. So you can see the sidewalk is parallel to this property line, and it gets fatter in here. Same thing here. And you go around the bend, the sidewalk remains in a constant position relative to the street line. So that's another reason for doing it that way, because I have something to, to refer to. Okay, so if you put it in the other position, if you offset 1.7 here and 1.5 to the other side, right? If you did that, right, if you kept a constant boulevard width but made this wider, it's not the preferred solution. Okay? This is really consistent with what the other designer did. It's very subtle, it's hard to see, but these are the details you need to look at to decide how to proceed. Okay? Some of you did it this way, some of you did it the other way. Neither of them is wrong, but this solution is preferred because it was proposed and accepted before. Okay, it's almost like learning law, right? You have to kind of see what the precedent is. What was done before? It was designed before. It was approved before. It was built that way before. Let's try and maintain some consistency, so people can find things easy in the field because they know exactly where it's supposed to be. Okay, any questions about the sidewalk? All right, so if you put a sidewalk on this side here, anywhere along this edge, I took a mark off. Okay, and if you didn't make the connection, at least one of these pieces, right? If you didn't go across to the property line, you should have done it 4 times. At least once, I would have taken another mark off, right? Because when you cross, you don't want to walk on the grass here to get to the other sidewalk. You want to make sure there's a concrete pad. All right? Okay, so you will have to adjust the driveways because of the sideway situation, okay? What else did I look at? Oh, the alignment. Here's a very important thing. There's 2 alignments, right? There's street B and there's street A. Those 2 are critical for our design. When you create the geometry, I looked for 2 things. I looked for the station value at the beginning and the station value at the end. Okay? And everybody should have the exact same alignments. So I put in what you're going to get back from me later today. You're going to see what the station values should be at the beginning and at the end. So if you drew the geometry correctly and you put 0 in the right spot, right, where the intersection of the 2 center lines is, you should get a station value here, a station value at the beginning of negative 10.25, right? Negative 10.250. That's the beginning, and that then proves that you put 0 in the right spot, the intersection of these 2 alignments. Okay? So the beginning station is 10 plus 250. The end, right, if that's in the right spot, which means you went all the way to the beginning of the alignment where the property line is on the opposite right of way for Ledger Way, that's the beginning, but 0 is here. So that's the station at the beginning. If the geometry is correct, if all the radii and the position of the center line is correct all the way around to here, the station value at the end, which is at the property line, ends here on the north side of Street A, should be exactly 629,418. And if it's not, there's something wrong. Okay, so if this doesn't match, and if this doesn't match the station value at the beginning, at the end, you're either not starting at the street line, 0's in the wrong spot, and if the 0's in the wrong spot and this if 0 is correct but this number is wrong, then somewhere between the 0 and all the way around there's a problem. Maybe your offset wasn't exactly 8 meters to center. Maybe your radius in the corners was wrong, right? If the geometry length is wrong, if the total distance to the end is wrong, then the geometry along the way has a problem. Okay, so you'll see I gave 2 marks, and if you didn't get 2 out of 2 for the alignment, then you have to fix it. Okay, and I gave 2 marks for the alignment of Street A and 2 marks for the alignment of Street B. If you did Street A correctly, 0 should be at the intersection of the 2 center lines, Ledger Way and Street A. It starts, because it's not exactly 90 degrees, at negative 10.259. That's the beginning. 0 is at the intersection, and positive chainage takes you all the way to the street line, the edge of the subdivision, right? Not the intersection, all the way to the edge of the street line. The station at the end should be 246986. So if this number's not there, I took a mark off. If this number's wrong, I took a mark off. Okay, so you had to have the extent. The geometry needed to be correct, and the definition of the alignment needed to be correct. Positive chainage increasing in this direction, 0 in the right spot. Positive chainage in this direction, 0 in the right spot. Okay, so that's what I look for. And you'll see a breakdown. All right, so that was, and that's critical. Going forward, you really need to look at that, right? If the alignment is wrong in any way, if you didn't get perfect on the alignment definition, you need to fix that. Now, the good news is if you started working on your profile, it won't matter, right? Watch this. If I take the alignment, right, and this is street A here, right? This one here is street A. Watch what happens. It's dynamic. So if I change this in any way, don't delete it if it's wrong. If I make it longer, watch what happens to the profile. It gets longer as well. So if there's an issue with street A or street B, you can revise it, never delete it. Revise it, and the profile is dynamically connected. So if you make it longer or shorter, the profile will get longer or shorter. If you change where 0 is, the profile will do the same thing. Okay, so you can see here, let me show you here. See 0? Station 0 is exactly where the crown of the road is for Ledger Way. Watch this. I'm going to change it. Okay? Right now it's correct, but I'm going to change it. So I'm going to go here. I'm going to go to the alignment properties, and I'm going to change the position of 0. I'm going to put it over here. It's wrong, but I'm going to put it over here somewhere. I'm going to say OK. And now the station is -20, around -20, right? So the crown of the road should appear near -20. So if we look here, right, there's the crown of the road, and it's near -20. So it adjusts. Because remember, we didn't draw any of this stuff. We just imported it. So if you change the alignment, they read the surface at the new location, they draw the profile from the surface at the new location. Okay, so don't be discouraged. If you have to update your alignment, don't delete things. Just fix it, and anything related to it that's a part of the database will automatically adjust. Okay, because I've seen students in the past, oh geez, I advanced all my design, and now what am I going to do? Just fix the alignment, and then everything else kind of takes care of itself. Okay, there are some things that don't, but mostly it updates. Okay, so let me undo that because I don't want that. It's wrong. I want to put 0. Okay, so 0 is in the right spot, so it'll show up properly on the profile. Okay. So those are some of the common things that that we looked at. The other thing was the surface. The surface was worth 4 marks. Okay, so the surface, I actually checked it in the topo file. Okay, but I'm going to show it to you here because we have a shortcut version of it. The surface, I looked at it in 3D Object Viewer. Okay, and I look at it as a conceptual, so it's all filled in. When I look at the surface, okay, even in the plan view, you should have made an attempt at cleaning up the edge. So that's 1 mark, the boundary. And when I go to Object Viewer, you should clearly see the ditch lines on the existing road. So see there, you can see the ditch line, 1 on each side. And if you look carefully, you can actually see the edge of pavement, edge of shoulder, and center line of the road. Okay, so if you look carefully, you can see center line, edge of pavement, edge of shoulder, and then there's the bottom of the ditch. And on the other side, center line, edge of pavement, edge of shoulder, and then the ditch line. Okay, so that should be clear. The road should be obvious when you look at it. Okay, the other thing that's obvious is on this side, you should see a ditch along here. Let me get a shadow on it. You can kind of see the ditch through here, right? There's the top, there's the bottom, there's the top. It's kind of a V shape, and you should be able to see it. Might be better with a shadow here. Just trying to get the lighting right. Yeah, there you go. So you can see a ditch through there. So if I see the road and I see the ditch well defined, I know you used brake lines. So I gave a mark for the boundary. I give a mark for the brake lines, and it's evident in the surface when you view it. I gave a mark for the points. You have to add the points, otherwise there's no surface. That's kind of a gimme, right? It's kind of an easy mark to get. And then I looked at it for spikes, which there are none, but I looked at it, okay? So those are the marks. There's 4 marks. If you didn't get 4 out of 4, that's something you need to fix going forward, Okay. A common error, a common thing that some people got wrong is they didn't use all the lines for brake lines, right? So then the road looks good, but then the ditch looked wrong. So all the polylines that should have been used as brake lines, not all of them were used. Another common mistake was to use lines that shouldn't be polylines, that shouldn't be brake lines as brake lines, right? So there's a set of lines that should be brake lines. Some people didn't use them all. Others had lines that shouldn't be brake lines defined as brake lines, right? So too many and not enough was kind of the issue for some people. Okay. If you're not sure how to fix that, let me know. I can show you. Okay. I can look at your file with you and show you where you went wrong, but it's certainly something you want to clean up. Okay, going forward, especially if it's a brake line issue, right? Because it may affect the volume of earthworks that we do later. Okay. So go ahead. Barry, do we need to fix anything in order to continue? The only thing you need to fix, and it's in the email you're going to get, the two alignments have to be correct. The surface needs to be correct. And the last thing is the edge of pavement. The edge of pavement is critical, and I'll show you why, which really leads into today's lesson. Okay, let me get rid of this. If you draw the edge of pavement in the wrong spot, hang on a second here. If you draw the edge of pavement in the wrong spot, let me turn off a few layers. Whoops. Sorry. Let me just get rid of some noise here. If you draw the edge of pavement, this green stuff, if you draw the edge of pavement in the wrong stuff, then these points, these key points in the plan, which are based on the edge of pavement location, the key points in the profile, right? If this is drawn incorrectly, then you can't design the profile of the road properly. You can't design the profile of the gutters correctly, which you will have to do. Okay, so the edge of pavement is worth 2 marks. I looked at it for standard position. It has to have a certain width. Remember, the dimension from center should be 4.3 on both sides, right? 4.3. So I look to make sure you have it in the standard position, and then I check the radii. If you use the wrong radius here, it's going to affect the design. If you use the wrong radius here, then this point will be in the wrong spot. This point will be in the wrong spot. If you use the wrong radius here, right, these points might be in the wrong spot. So it's critical that you get the edge of pavement, right? So what you'll do is, just like in CDA, you'll get the breakdown of all the marking, and then I've highlighted the key ones that if they're not perfect, you have to adjust before you go forward. Okay, any other questions about that? I want to talk about one more thing before I begin. Okay, I've been talking for a long time, but these are important things, okay? This discussion that we're having now makes more sense after you try the stuff I asked you to do, okay? And I know you're sitting there, some of you are saying, well, if you had told me that before, yeah, I can tell you lots of things before, but then you don't try them yourself. You don't attempt them yourself. You don't think for yourself. You don't become that independent designer you need to be. So I can tell you the rules, and then when something out of the ordinary happens, that's what you need to think about on your own, okay? So now that you've been kind of had the experience and tried something, now that I'm giving you a better idea of how to proceed, it makes more sense. If you don't try it, if you don't try and figure it out first, then my suggestion isn't going to help you. It's just going to tell you the answer, and then you're not going to learn to think for yourself, okay? So that's why I didn't take marks off for how you connected to the water main, as long as you made a connection. But if you used a bend, it's not going to work very well, based on the rules that I set forth, right? Do you want to fix that? It's not necessary going forward. If you do want to fix it, I suggest you use a radius. Okay. Now, why would you fix the other things that aren't necessary for this course? Is because if you're creating a portfolio of drawings, you want to fix these little things. Okay. So on your own time, right, and not right away, because it's not the important thing for this course, but anything that you got wrong or wasn't correct or could be fixed that's not necessary going forward, you may want to correct them so that when you print off a set as a portfolio, something to show somebody, then it looks better. Okay, so you don't have to for the course, for me, but you may want to. Okay, so I've given you the absolute yes, you must fix this, but anything else you got wrong, you may consider fixing it for your own purpose or for your own need later when you're doing a portfolio. Okay. The other thing that was an issue was the hydrants. So did anybody use more than 4 hydrants on the site? I don't think anybody did. Most people had 4 hydrants, 2 on street A and 2 on street B. Okay. I did my best to design it with 4 hydrants, and it's not possible. Okay. You need 2 on street A, but you're going to need 3 on street B, and I'll show you the coverage. Okay. If your house is facing a road, then the hydrant to fight the fire at your house needs to be on the same road. You can't go around the corner to get water for a house. Okay, so when the fire department shows up at the front of your house, they just want to look one way or the other, left and right from your house, and find the nearest hydrant. They shouldn't have to go around a corner. So when you're doing these circles, these circle coverages, you have to include the entire property for the hydrant on the street. Okay, this is what I'm talking about. Let me have that discussion on street A, and then I'll show you on street B why you need 3. Okay, so I put my hydrants, just turn everything on again. I put my hydrants here. Okay, whoops, what did I do here? Okay, so I put my hydrants here. I put my hydrant in front of lot 47, and I put my other hydrant in front of lot 38. Okay, and I offset them by 1 meter from the corner. Offset them in by 1 meter on the corner. Why? Why? Because all the hydrants are located that way. Oops, this is typical. 1 meter from the corner to the hydrant, right? 1 meter. Look at any hydrant, it's always 1 meter. Let's look at another one. Here's another hydrant, 1 meter away from the closest lot corner, right? The driveway site. Look at any hydrant, they're all 1 meter away. Here it is. This one is actually right on the property line, so there's no dimension. This has a 0 offset, but this is in front of the townhouses. But on the single lots, which is what we're dealing with, all of the hydrants are 1 meter away. This one's not labeled, but it's 1 meter away from the corner. Let's look at another one. Oops. Hydrant, 1 meter. Okay. So from the corner, the closest corner, not this corner, but this corner. Remember, this hydrant is in front of this house. So it's 1 meter away from the close lot corner. And that's typical. So that's what I did. So when I do that, I'm going to draw a circle from the center. Circle from the center, 75 meter radius. And I'm going to do that for this one as well. 75 meter radius. So now, only street A needs to be thought of. These circles are for street A, okay? These circles intersect, and all the lots, this entire lot, this entire lot, this entire block, right? And all these lots, 50 all the way to 42, right? These are all inside this circle, all right? These two blocks, and all of these units are inside this circle. In here now, you'll see where this circle falls short. This circle does not cover lot 41. This circle does. It covers all of lot 41. Lot 42 is entirely covered by both circles. That's good. Lot 43 is entirely covered by this circle, right, and most of this circle. Okay? So even though this doesn't have coverage by this hydrant, it's covered by this one. Okay, so all of these units and all of these units are in the area bound by these two circles. How do I know? Watch. I'm gonna draw a hatch. So I'm gonna hatch select. I'm going to hatch this one, and I'm going to hatch this one. I'm going to push them to the back. Okay, so you can see everything from this property line and this property line north, right? All of these units are inside the area bound by these two circles. Okay, the hydrants for all the homes on Street A service all the homes on Street A. So to fight a fire in any of these units or in any of these units, you can use the two hydrants on Street A. So the houses front onto Street A, the hydrant to fight those fires is on Street A. Okay. When it comes to Street B now, I'm going to draw I put a hydrant here, lot 19. I put another hydrant here, lot 9. Okay, so I'm going to draw these circles. 75 meters. I'm going to draw this circle, 75 meters. I'm going to draw the circle up here, way up here. Okay, so I've got this circle and this circle. Now you can see part of the road here has no coverage. Okay, if there's a fire on the road, then you can do whatever has to happen. So I'm going to draw a circle here. Okay, this is about the houses, not the roads. So I'm going to use this circle, 75, and you can see now I can fight the fire on the road from this hydrant all the way down to here. I can fight the fire on this section using this hydrant and this hydrant, and then this little wedge in here that's not covered by either of those two circles, we can use this hydrant. At the intersection, you'll be able to see this hydrant. Okay, I don't have to go around the corner. When you're in the intersection, you can see that hydrant. Okay, so the issue is here. This is good. This covers all of the lots all the way up to here. And this covers all the way up to 14, right? So these are all covered by this hydrant. That's good. This hydrant covers all of these and 4 and 5, but not 1 and 2. See 1 and 2? The backyard, if there's a fire in a shed at the back of the lot, or most of this is not covered. Now you might argue, if I draw a circle here, 75 meters, well, lot 1 and lot 2 are covered by this hydrant here. Yeah, but this hydrant is not on Street B, so I can't use this to fight the fire. So they really want you to make sure you have coverage. So then I put another hydrant here. 75, and now I have lot 1, 2, 3, 4, 5, 6, and 7 covered by that one. This one, there's a huge overlap, but that's just the cost of doing business. If I try and move the hydrant over, right? If I try and move this hydrant, think about the center here, right? If I try and move this hydrant over to cover the backyard of lot 1, now I've lost coverage in the back of these two units. Okay? If I try and push this over to get the gap, to cover the gap here, now I'm starting to lose coverage on the road here and on this lot here. Okay, so the solution for this particular subdivision layout, the one I've provided for this year, and it changes every year, you're going to need 3 hydrants on Street B for that reason. Okay, so this has to be 75. So you're going to need 3 hydrants on Street B, and now this one can move over, right? It doesn't have to be exactly where I put them. I can move this over. Right? It doesn't have to be here. I can move it over 1 unit or 2 units and still have coverage. Right? Extra overlap here, a little less overlap here. So I can move the hydrant. Instead of putting it here, I can put it here. So I'm going to move the hydrant with the dimension line from here. I'll put it over here. Right? That's the center of this circle, and I still have coverage. Okay? And that might be a better distribution. So there's more than one solution. Okay, so the general rule is to fight a fire on a road, if the house address is on that road, then it's the hydrant on that road that needs to do the job. All right, so in this particular subdivision, we're going to need 5 proposed hydrants, 2 on Street A, 3 on Street B. All right, I don't think anybody got that. I think everybody missed the backyard stuff. Okay, so you have to make sure you have this full coverage. And this is exactly how they check it. They'll draw all these circles. I did take 1 mark off for the hydrants. Yeah, if you didn't have more than, if you had 4, I took a mark off. You need 5. Okay. The other argument, and I've had this in the past, there's a hydrant right here. There's a hydrant right here, right? This hydrant here, right? It covers lot 6, lot 5, lot 4, right? This circle covers these 3 lots. Everybody agree with that statement? Yeah, Samuel, this is exactly what I'm getting at. How do you get to this hydrant if this is the back of the lots and there's a fence here? So that hydrant is not on the road that the houses front onto. You don't have access to those backs through the fence. So yeah, that hydrant on the map is closer, but it's not practical to use because you have to go through the backyard fence. There will be a fence there. Those are backyards. Okay, this is the back of the lot. This is the front of the lot where the driveway is. So I've heard that argument in the past. It doesn't work. Ran, the size is the round one, not this one, but the round one. So it's the 400.01 HR4 or RH 400.01. The diameter of this is the inside diameter on the standard. Look up the standard. Right, so if you go to the town standard, or not the town, the region standard, where is it here? Region of Halton standards, and you go to the standard drawing, whoops, 400.01. This is 400.01. Use the inside diameter. Inside diameter. That's how I draw it. Okay, so I hope I've given you some insight. I hope this discussion today makes more sense than it did when I taught it to you. Again, the only way to learn how to adapt the standard when you're in a non-typical thing is to try something. You have to propose something, okay? I'll give you some advice, you know, as we go, but I can't, I want to avoid, and I've done this in the past, I have to avoid telling you exactly what to do. I just have to teach you the standards and give you some rules of thumb, some guidance. And then when you get into the details, if it doesn't fit exactly what I described, you have to make a design decision. You have to determine, hey, how am I going to do this, right? Okay, I know the standards. I see what the other subdivision designer did, so I've got another idea there. And now I need to make a decision, okay? And try and keep it as standard and as typical as possible, okay? And again, there's no wrong answers, but some solutions are better than others. Some are more elegant than others. Some are more efficient than others. And sometimes the best solution is the most cost effective. What's the cheapest thing to do, okay? And there's more than one solution. There's always more than one solution. Okay, so we don't talk about answers. We don't talk about the solution. We talk about solutions, right? And there are many. All right. So again, I'm going to distribute after class later tonight, probably after supper, sometime after 6. I'm going to distribute marking for the assignment, and you can see, and it's clearly marked with what, if it's wrong, needs to be fixed. And if you're not sure how to fix that, then email me and we'll set up a meeting and we can discuss the details. Okay. So today, I know I've taken up a lot of the time already. It's been almost a little over an hour. Let's take a break. So it's 2:41. Let's take a break. Let's say, can we do 15 minutes? You want to take a 15-minute break? Does that make sense? Okay. Do you want to take a 15-minute break? Yes or no? Majority rules. So it's 42. So let's come back at 57. Why don't we just come back at 3 o'clock? How's that? 3 p.m. Okay. So we'll start up again at 3 o'clock, and we'll look at the road profile design. which you're going to need for the grading and the servicing. Okay, we're back. So today I wanted to cover how to design the profile. Okay, and there's a technique we're going to review and a new technique I'm going to introduce, but it's not that big a stretch from what you already learned. Okay, so before I get started, I want to work in my profile. So I'm going to type in UCS, make sure I'm in the world coordinates, and that's indicated by the icon here with a little square in the origin. So I know that's true north in this direction. And I want to rotate the space so that the profiles are now horizontal to the view. So I'm going to type in plan and hit enter twice. And that rotates the space, so now I can comfortably work in the profiles without getting a kink in my neck. Okay, so the design for this, again, requires, and let me freeze out a bunch of layers because there's a lot of noise here. Oh, by the way, during the break, I fixed all my driveways. Right, I revised all my driveways where there's no sidewalk. So that didn't take too long, in case you're wondering. So let's turn off the driveways, the water, sanitary, storm, water main, valve chambers, valve boxes, dimensions, all this stuff. It's just a lot of noise. All we're interested in right now is to see the center lines and the edge of pavement. I don't even need the back of curb, okay, the edge of pavement. So there is a PDF that was posted. Professor Neruzzi, I believe, revised it so that the correct one is actually posted now, right? So he's updated this. So I'm going to start here. Let me describe what I want to do, and then I'll go ahead and show you how to do it. Okay, so I want to design Street A starting at the existing intersection, and I want to design it all the way to the low point and to this intersection, right? So I want to design the profile from here to here, and then I'm going to stop. Then I'm going to design the profile for Street B from here all the way to the elbow and all the way to this elbow, and then I'm going to stop, right? And then I'm going to design the rest of Street B between this point and this point. I have to kind of close the gap. So I already digitized this. I hope you did also, right? The original design for Chuchmak. Now I'm going to start at the end and go from here all the way to here so that this end, so the beginning is existing. We digitized it, the existing design. We're going to propose our design all the way to here, and then we need to design along this stretch of Street B. Once that's complete, then I'll have the elevation at this end of Street A, I'll have the elevation at this intersection of Street A, and then we'll complete the design for Street A. Okay, so before I proceed, I want to solve my elbow problem. What is the slope of the center line to guarantee the gutter grade on the outside of the turn? Did anybody do that calculation? Did anybody do that calculation? Okay, 105. Anybody else? 1.5, okay. Okay, so I'm going to create the geometry required for doing that, okay? So I'm going to use this technique. I'm going to offset my center line alignment by 1 meter. It's going to create a polyline. Well, it's going to be on the current layer. Hang on, let me make the layer current. So I'm going to work on the edge of pavement layer. Hang on, I'll set this current. Set current. Okay, I'm going to offset by 1 meter. And then I'm going to offset that back 1 meter. So now I have a polyline where the center line is supposed to be. Okay, so I don't want to delete the original line, but I want to trace it. So there's a quick way. Okay, here's a technique. This is an alignment. I'd like to have a polyline there. Okay, so I don't want to explode this, obviously. So I'm going to offset by 1 meter, and then I'll go 1 meter back. And now I've got a polyline exactly where the center line is supposed to be. I'm going to make a copy, okay, and the widening, right? This is the last time we have a typical. This is the last time we have a typical width. What's the width? If I draw a line from here, perpendicular to here, what's the width of the road? Edge of pavement to edge of pavement. Anybody remember? Anybody? No? Samuel? That's edge of asphalt to edge of asphalt. Edge of pavement, gutter to gutter. What's the dimension? 8 is the asphalt edge to asphalt edge. Anybody? 8.6, that's correct. So if you drew it correctly, the width from edge of gutter to edge of gutter, or pavement to pavement, it should be 8.6, right? 4 meters plus the gutter width, 4.3 times 2 is 8.6. So on half of it is 4.3. There's 4.3. On this end, you have 4.3. And everything between these two along the elbow is going to get wider, right? If I draw a line from the midpoint here to the midpoint here, it's no longer 4.3. This is the widest part of the widening. It's 5.25. Okay? So it varies. On the inside, it's constant. Between here and here, it's exactly 4.3. But from here to here, it gets wider. And you can see why. This center point and the center line center point are in the exact same spot, right? So these two are concentric circles. This is the center of both of those arcs. This one is somewhere else. The center of this is over here somewhere, right? If I explode this, I'm going to undo that, right? But the center of this is right here. The center of this is exactly in the same spot. So these two are concentric. They're in the same center. This one is not. Right? You can see that's not concentric. Okay? And you'll see here, right? The end of the curve, the end of the curve, and the end of this curve, they don't line up across the alignment. Okay? So the geometry I'm looking for is between these two lines and between these two lines. So I'm going to make a copy. Okay? And you have to do this 3 times, right? There's 3 different elbows, but they will be very similar. So I'm going to bring this here, and I'm going to trim from this point to this point the edges. And now I have the length. This is made up of a line, a curve, and a line. I have this polyline length. That's the length of the gutter. And I have the length of the center line. That's the length of the center line. Okay, so what is the minimum gutter grade? Does anybody remember? What's the minimum gutter grade? 0.75%. So we're going to take the length of the gutter. I'm going to list it again. I'm going to take the length of the gutter, which is 28.162, 28.162, and I'm going to multiply by 0.0075, which is meters per meter, 0.75%. And that value is the rise of the slope, right? The elevation difference between this point and this point. Okay, that's the rise. So the length times the slope gives me the rise. Then I'm going to apply that rise to this position. I know the rise is going to be the same. I'm going to take that rise and I'm going to divide by this length, which is a little bit shorter, so it should be steeper. So now I'm going to take that rise and divide by 20.42. 20.420 equals times 100. Okay. So let me do that. Can you see my calculator? Can everybody see my calculator? Yeah, okay. All right, so here's what we do. We're going to take the length, 28.162. I'm going to copy that, put it in my calculator, paste it. I'm going to multiply by 0.0075. That's the length times the slope gives me the rise. So that's the difference in elevation. And then I'm going to take that and I'm going to divide it by the length of the center line, 2042. So divided by 20.420 equals times 100. So that's the center line slope. So if the slope of the center line in that widening zone is 1.034353557%, then that makes the gutter exactly 0.75. Okay? Now the reason we're doing this again is I have to design the center line so that the gutter works out in the end, right? So this is what I said last semester. The phrase I like to use is the tail's wagging the dog. I need to describe the dog to make sure, you know, that the tail is doing what it's supposed to do. The tail wagging the dog. Now, I don't want my design to be this number here. It's huge, right? This is kind of a weird number to work with. So now I'm going to round this up, which makes the gutter steeper than 0.75. So then I satisfy the minimum without using a really weird or non-standard value for the center line. Okay, so if I want to round this up and keep it as low as possible, remember I'm trying to achieve minimum slope everywhere, I'm going to round it to 1.05 or 1.1. Okay, so I'm going to use either 1.05 or 1.1%, okay? One or the other. I'm going to have to make that determination. You choose. Okay? If you want to be really tight, 105. If you want to be a little bit flexible, use 1.1. Okay? I wouldn't push it to 1.25 or 1.5. That's unnecessarily steep. Okay? Why? Because as I suggested in previous classes, this design is going to be mostly in a fill. So I want to keep all the slopes as flat and as low as possible. I want to reach from here all the way to here, and from here all the way to here at the minimum slope, to keep the elevation of the road as low as possible, because the existing condition is even lower than that. Okay, and you can start to see that in the profile. Here's Street A, right? I'm connecting to this. The existing ground is down here, right? So when I design this, right, I want to keep this as flat as possible, because if I go steeper, I'm creating a lot of fill. Right? I'm going to be in a fill anyway, but I don't need to be steeper and create a worse problem for the earthworks. So I'm trying to reach as far as I can with the minimum slope. But to go around the elbow, the minimum slope can't be 0.5%, which is the recommended minimum. It has to be steeper to satisfy the gutter grade. Okay? Do you remember this discussion from last year in CDA? I hope. Okay, so between the intersections and the elbows, and between the elbows, I'm going to use 0.5%. But when I go around the curve, I'm going to go a little steeper so that the gutter works out. So I'm going to use 1.1. You can use 105. And I've only checked it here. You should do this calculation for all 3 elbows and satisfy yourself that 1.1 works for all of them, or 1.05 works for all of them. Okay? And try and use a standard number. Use the same value all the time if you can, right? That way it's typical, right? So figure out each one, round up so that you're higher than each calculated value. So I think 1.1 will work everywhere. You convince yourself, though. I'm not going to do the other calculations, okay? You guys try them. All right, so I'm going to use 1.1 on the profile between this point, and between this point and this point. And you'll notice here, it works itself out. In the elbow, according to the profile, the slope in here is already 1.5. The existing profile through here is already 1.5, steeper than 1.1, so I know this elbow is going to work. I'm not worried about this one. Okay, and how do I know that's 1.5? We go to Chukmak profile, which is this one, right over here. The profile of the road over here is 1.5, 1%, right? So right around here, we're going to use 1.5, so through here. Now, the alignment's going to go along here. It's much further out and then come down, but it's going to be close enough. Okay, so whatever's happening here should be fine. So I'm going to use that 1.1 again. Sorry, the 1.5 again, from this point to this point. Okay. So to get started, I need to find key places in plan and project them to the profile. Sound familiar? So I drew all the key points in plan, okay? Here's the edge of pavement on the original road, right? There's the edge of pavement. Here's the center line of the road for reference. We really don't need it because we have the corridor surface for Ledger Way. Here's the 2 points at the end of the curve here and the end of the curve here. We're only going to use one of them, but I'll project both. Here it's obvious. You can see that this one's further back, but I'll project both. And you'll see it in the profile. Whichever one is further back, that's your low point. Last year, these points were so close. It was almost 90 degrees, right? It was almost 90 degrees when we did CDA. Here, it's a little more obvious, all right? So really, if you want, you could just ignore this side and know that's the low point. But in practice, I always show both. And then when I project both of these, you'll see this one's further away from the intersection than this one, okay? So the key points to look at are going to be, and here's here's the process we used last year, right? And let me expand my AutoCAD so you can see the words. So under the profile view, we go to project objects to profile view. So I want this for reference, I want this for reference, and I want these two for reference. And I want to design all the way to the first intersection, this one here. Okay, so those are the points for the first part of Street A. I go to the profile for Street A. And instead of bringing them in at elevation 0, I'm going to make sure that they're all original ground. I want to bring them into range. Otherwise, the scale is going to be affected, right? So they're all here. I'm going to say OK. So now I have all the station values. The elevations are garbage, but at least the station values are correct. Okay, so you'll see this one's at the crown. You'll see this one is at the edge of pavement or the gutter line. And then you see these two. Which one's further away? This one is further away, so I'm going to delete this one. So that's where my low point's going to go. And then here's the intersection elevation. That's all I want to design for now. Now, the stations are correct. None of the elevations of these 4 points are correct. Okay, so here's what we do. We're going to start digitizing the design. So I'm going to go to Profiles, Create from Layout, pick the grid, change the name. I always repeat the alignment name, and then I put in an FG for the profile, finish ground, and I say OK. I get this dialog box, and now I want to create PVIs. Okay? I'm going to set my OSNAP to node and endpoint. Now remember, if you drew this the way I suggested, 0 is here, and it's increasing from the right toward the left. It's backwards, right? 0, 20, 40, 60. So now when you digitize, you want to go in the direction of increasing chainage. So this is the beginning, and I'm going to digitize this way. It won't let me digitize backwards, I don't think. Okay? You have to start at the beginning and move your way forward. Okay? So I'm going to snap to the intersection of the crown, which I really don't need because I'm not replacing it. Right? I'm going to snap to the edge of asphalt, and I'm going to snap to this node. That's the edge of pavement or the gutter line. I'm going to snap to the low point, and I'm going to snap to the intersection of street B, and I'm done. Okay, so now I have my database. So what I want to do is take this slope, whatever it is, and extend it to the gutter point. Right, so I want this vertical line, I want it to have the same slope as the edge of asphalt. Now, it will be very close to 2%, but it's not going to be exactly 2%. Why is it not going to be exactly 2%? Because the two roads do not meet at 90 degrees. So if you look at the plan view, right, the angle between this line and this line is not exactly 90 degrees. So I'm not looking at a line that's a cross section of Ledger Way. I'm looking at a section that's not at 90 degrees to the center line of Ledger Way. So it's going to be very close to 2%, but it's not going to be exactly 2%. Okay, so when I look at this, I'm going to look at the table. So I'm going to click here, click at this table, right? And you'll see it's not exactly 2%, right? So we're going to use the grayed out column to go forward in the direction of increasing chainage. Okay, so from the center to the edge of asphalt, it's minus 2%. Then you have this steep slope. Well, I want to repeat the slope, so I want whatever this is to be repeated here. So minus 2.2, not minus 2.02. And now I extended this pavement line from the edge of asphalt all the way across to where the gutter line is, the projection of the gutter line. We're going to get rid of this curb and gutter, right? It's going to be ripped out. So I want to extend all the way to the edge of pavement, the plane of the crown of the road, right? So if this piece here is 202, then the extension is also 202. So there's my first design point. And that's exactly what they did on Chuchmak. Remember, this is Ledger Way. That's the profile, that's the cross section of the surface for Ledger Way, right? Remember when we did the corridor? And you'll see the design actually is exactly at the edge of pavement where the gutter line is, right? So this really doesn't exist. This part really isn't real, right? They're connecting to the edge of asphalt and extending the plane to the gutter position. And we're going to do the exact same thing. Okay. In this case here, this is exactly 2% right here. This is exactly 2%. I'll show you if you don't believe me. It's exactly 2%. Profile geometry. It's exactly 2% because the roads are at 90 degrees to each other. So up here, whoops, Ledger Way and Chuchmak are exactly at right angles to each other. So you get exactly 2% because the profile of Chuchmak is perpendicular to the alignment of Ledger Way. Here, that's not true. It's a little less than 90 degrees. Okay, so let's go back to Street A, and we're going to change the design. Profile view, sorry, profile, properties, geometry. Okay, so the first one, we match it with the next one, so the little gutter is the correct slope. Then from there, we're going to go to the low point. What's the slope down to the low point? Anybody remember? What are we going to do to go down to the low point? What slope should we use here? Yeah, more specific, Samuel. You're kind of right. It's actually minus 0.5. We're going down, right? So there's the low point, and then from there we go up at positive 0.5. Okay, so now I've designed the profile of Street A from Ledger Way all the way to the intersection where Street B ends. Okay, you don't really need this for reference, right? But it's something that you have to kind of start with, right? So once you create the cross section that you're going to connect to, you don't really need this anymore. But if you want to keep it for reference, you can. I wouldn't keep it for a couple of reasons. One, this boulevard is not correct. It's actually going to come out, right? So that really isn't realistic. If you want, you can add PVIs to trace this, right? So you can add a PVI here, back of curb, front face, gutter, edge of pavement, right? So there's the complete profile, and then get rid of the surface. This is the surface, right? Get rid of the corridor surface, and that's what the design will ultimately look like. Okay, so that's really what we're designing. This half is existing, this pavement is existing, and then from there we're actually doing our design, right? So our design really starts here, right? At the edge of asphalt. This is the first design point. Okay? If you want to keep it for reference for a while, you can, but I wouldn't show this in the design. It's only to get started. Okay, it's like when you project points, right? Now that these points are traced, you don't need them anymore. That's my design, right? But why are those points at those station locations? Because of these key locations in plan. The station locations in the profile come from key locations in the plan. And that's why we project the points from plan to profile. Once you trace them, right, you've established the stations in your design, you no longer need the reference points. So you can delete these, they're not going to change. And you can delete this, you're matching. Okay, so there's the design. So I'm going to stop there. Now I'd like to take that elevation and bring it to the end of Street B, right? I just designed from here all the way to here. Now I know the proposed elevation for this point here. I'd like to take that and bring it into the profile at the end of Street B. And I'm going to design this going backwards, up chainage instead of forward and chainage, okay? So here's the new tool, the new trick, the new technique. We've been projecting points from the plan to the profile. Everybody's familiar with that, right? You take the point, project the point from to the profile view, right? I'm going to take the point from the plan and bring it to the profile, right? I'm going to bring it to the profile. I don't like the elevation, so I'm just going to change it so that it's in range, right? So I'll project it to the existing ground. And now I know that position. So from the plan, I've gotten the station location into the profile. Now I want to go backwards. I know the elevation of this point in this profile. I'd like to project it to the end of Street B, the crown of the road at the end of Street B, so that I can design backwards, right? From here all the way around to this point, and then we'll discuss this. This is the most difficult part. Okay, so this is a two-step process. What I'd like to do, and there's no tool for it, but let me describe it. What I'd like to do is take this point from this profile and project it to its corresponding location in this profile. Okay, what does that look like in the plan? For Street A, this point has a station value. Agreed? Right? It's 40 something, right? This has a station value, 40 something. Let's look at it. Right? Station 4743. It has an elevation that I designed in the profile. If you look at Street B, this point also has a station value. It's 620 something, right? If you look at this alignment, it's 620 something. So I know the station on Street A, and I know the elevation that I designed in Street A. I know the station on Street B, and I want the elevation at that location to be the same. It's the same point in space, right? The intersection has the same elevation. This is an at-grade intersection. It's not an overpass, right? So the elevation is the same on both profiles. Two different station values, depends which profile you're looking at, but the same elevation. There's no tool to take this information from the profile and bring it directly into this profile. Okay? There's no one step. So you do it in two steps. So we have been going from the plan to the profile. Now I'm going to go backwards. I'm going to project a point from the profile to the plan. This is what's new. From the profile to the plan. And here's how you do it. Watch. This is the new tool. We're going to create a point, create points. You remember this from grading, right? Remember all of our how to import the points, and then my high-low distance command. So you're familiar with this, create points dialog box. And if you go to the third button, there's this command here, station offset. This is the one that allows you to project from the profile to the plan, not from plan to profile. So when you start this function, pay attention to the prompts at the bottom in the command line. Select the alignment. I want street A, so I'm going to click it. I'm going to pick street A. I don't even have to know the name. It's this one, right? Click on it so it knows it's street A. Then what elevation do you want? Well, there's 3 here. Well, there's 2. There's the profile that I designed, and then there's the surface, which is the existing ground. Make sure you pick up the design, the profile of the proposed ground. So that's where the elevation comes from. And now I'm going to say OK. And then it's going to prompt me, right, where. So now I'm going to snap to the node. When I snap here to the node, it's going to pick up the station value on street A. And then it's going to say, do you want an offset? Say no, right here, offset. Just hit enter. We don't want any offset. It's going to put the point right on the mark. And then you're done. So this point came from this alignment, horizontal, and this alignment, design vertical. Okay, and you'll notice the elevation is 194,718. It's not a coincidence. I took that position in the profile and put it on the plan. Okay, anybody want to see that again? Do it one more time. Do you need to see it again? I'm going to do it a couple more times, but everybody comfortable with that? Okay, let me do it one more time. I just want to make sure you understand this. Okay, I want to project this elevation from the profile to the plan. So I use this button here. Let me start right from scratch. Points, create points, button in, top 1, station offset. Which alignment? It's prompting me for the alignment. So I'm going to pick street A. Which profile? Where does the elevation come from? The design profile, not the existing ground. Say OK. Then you snap to the location, node. It'll pick up the station value. Offset 0. When I hit enter, it puts the elevation of that alignment from the design profile onto the plan. Now we do what we did before. Project the point to the profile. Which point? The one I just created. Project the point to the profile. Pick up that elevation, that point, hit enter, and go to street B. It's going to come at the end, right? This is Chuchmak existing, and this is the end of the alignment where the intersection with street A is. When I click here, here's the secret. Don't change the elevation. Keep the design elevation. You don't have to put this into range. It's already exactly what you want it to be. So when you project this point, not only are you getting the station value, you're also getting the design elevation you want. So don't change anything. Use the elevation. Whatever elevation value is here, you want to use that value. So when I say OK, there's the crown elevation, 194,718. And now the elevations match, 194,718, 194,718. So to project this elevation to this other profile, it's 2 steps. Take it from the profile, project it to the plan, and then whatever the result is, project that to the other profile. And that's the secret to this. Okay, so now we can go from plan to profile. That's what we learned last semester. This semester, I'm teaching you to go from profile to plan, and then the tool I taught you last semester, go back to a different profile. Any question about that? Okay, that's a new tool, a new application, from profile to plan. And you're going to use that tool a couple more times, okay? But it's important. Now I want to design this alignment, this profile, all the way to here. As a matter of fact, I want to design it not to the end of this curve, not to the beginning of the curve, but 10 meters away and 10 meters more, right? So how did I locate these 2 points? Well, they're on a straight line, so I just drew a circle from this endpoint, 10-meter radius, and I put a point there where the circle intersects the alignment, and then I offset the circle 10 more meters, and that's how I located this point. So that's how I plotted this point and this point. Okay, so these are the BC and EC. They're easy, right? It's just this you can snap to the end point, right? Here you need to draw these 2 circles and then put a point there as well. So now I want to project the special points in plan to the profile. This is exactly what we did last semester. So I'm going to go project points to profile. I want the center line. Really doesn't matter because I already have it. I want the edge of pavement, right? That's the extension of the gutter line, right? So how do you draw this point here? You just draw the line from here to here, right? Or more accurately, you offset 4.3, the center line, and that's where that point is, right? There's your edge of asphalt on the through road. This is the major road. This is the minor road connecting to it, right? So that's the edge of pavement. So that's how I drew that. These are on the end of the curve. This is exactly 90 degrees, so these will be at the same station value, right? So I'm going to project both, but I really only need one. They're both equidistant from the intersection. Okay, so I'm going to pick up all these points, create profile, project objects to the profile. I need this, not really. This is important. These 2, I only really need one, but I'll bring both. And then I want the end of this curve, the beginning of the curve, the end of this curve, the beginning of this curve, and then these 2 points here. Okay, so those are all the station values. Elevations, I have to design that. And I come into here. Again, these are all, whoops, then these are all 0. These are all 0 elevation. You can see here, they're all 0. So to bring them into range, because again, it's the stations I'm interested in, I'm going to design the elevations. I'm going to project them to the original ground just so they're in range. I'm going to say OK, and then they'll all be touching the original ground. And now I want to digitize these points. Now I'm not going to create a new profile. I already have a design profile. I'm going to add to this database. Okay, I'm not going to change this part of it, but I'm going to add to it. So how do we do that? You click on here, you right click, we go to Profile Geometry, and we use this button to add more PVIs. Okay, so I'm going to click here, and now I'm going to snap to all the nodes. 1, 2, 3, oops, I missed that one. Let me try that again, sorry. 1, 2, 3, 4, 5, 6. These are, I can pick either one here. This is the low point, right? So I'll pick this one, doesn't matter. That's the edge of pavement, and there's the crown. Now, if I pick here, it's wrong. I really want to pick here. This is the starting elevation, right? This gives me the station. This point that I projected before gives me the station and the elevation. So this is really where I want to start. And now I can delete all the reference points. I really don't need them. So they're going to clutter my view, so I'm going to get rid of them. So all the points that I just traced, I'm going to delete. Right? Now I've established the stations I want, and I can just design my profile accordingly. Okay, so the first one was the point that we projected that came from street A, right? This one here. This is really my starting point for the design. This is the starting station. This gives me both station and elevation for the design. So we go back to here. And now I want to design the slopes. All the slopes are screwy, right? They're all wrong. 0.83, 16.3. This one here is 0.71. It's all garbage, right? So I have to design this. Now here's what's new. We're designing backwards, right? We're starting at 620 and we're going backwards. So now we have to do something a little different. We go to the panorama view, and we look at this. We start backwards. So actually, we start at the bottom. In this design, we're going to start at the bottom, not at the top, right? Not at the beginning, but at the end. And remember, if you start at the beginning, you type into the grade out column. If you start at the end, you type from the bottom up in the grade in column. So if you start at the beginning, you start typing in the grayed out column. And that's how we got to here. This is the design, right? -2, -0.5, +0.5, +0.5, 1%, 0.5%, 1.5%. That's how we typed in this stuff here, right? 2%, 0.5%, 0.5%, 0.5%, 1, 1.5. We typed those in from the beginning in the direction of increasing chainage. Now we're going backwards. Right? So we're not typing in the grayed out top to bottom, we're typing in the grayed in bottom toward the top. And watch the graphic do its magic, right? Whenever you do here, you're going to immediately see the results here. So what's the slope of this one here? What's the slope of the first one? What are we going to type in here? Remember, this is the pavement. That point with the triangle on it, this one here, is the crown of the road, the center line of street A. So what's the slope of this? What are we going to type in here? Anybody? What's the crossfall on the pavement? Okay. Anybody else? You're half right. Ryan, you're not as specific. Although technically you're correct. The slope of that line, if you're driving from here to here, you're going -2%. That's true. However, in the direction of increasing chainage, 600, 620, when you go from this point to this point, the slope is actually +2%. And this takes a while to get used to. Okay, that's why I'm being really slow here. The slope here is 2%, but what do you type into here? What do you type into here? You have to type in the slope as defined by the direction of increasing chainage. So even though we're designing backwards, the slope's plus and minus sign is based on moving forward. So if I put -2% here, watch what happens. -2, it's downhill, it's wrong. Right? Because from this station to this station, we're moving in the direction of increasing chainage, and that's a positive slope. So even though we're designing backwards, the slope definitions are still based on moving forward. So the slope of this piece here should be +2%. +2. And now it looks like a crown. Okay? So if you go from here to here, yes, you're going downhill. But the slope of this is based on moving in the direction of increasing chainage, so it has to be positive. And this takes a while to get used to. When you're designing backwards in chainage, the slope definition is still based on moving forward. Okay? So it takes a while to kind of get used to that, but that's what you have to do, because the definition of slope is based on the direction of increasing chainage. So what would the slope of this line be if we want to have a low point? What would this next one be? I want to go down to a low point from the edge of pavement. What slope would I type in here? Yep, you know it's 0.5%, and again it's positive. From the low point up to the edge of pavement, it's positive. Even though we're going backwards to that point, it's positive up from that location. So this would also be +0.5. So +0.5. You don't have to put the plus sign in, but I'm just emphasizing. So now from the edge of asphalt, you can see we went down to the low point, but the definition of this slope is a +0.5. Now from there, we're going to go up to the first bend, right? Don't forget what's happening in the plan, right? We just designed this elevation here. So we went down here with a +2%. Then we went down to here with a +0.5%. And now I want to design from this low point to the end of this curve. I want to establish this elevation. What's the slope from here to here going to be? Which is this stretch right here, which is this input right here. On the straightaways, I'm going to use the minimum slope. What should I type in here? Exactly. So it's still going to be percent, but now we're going down to the low point in the direction of increasing chainage, negative 0.50%. And you can see that. What was the minimum slope? This tangent is the beginning to the end of the curve. What slope are we going to use there? Tron? Not quite. I'll type that in, 1.1. Does that look right to you? What should it be? Negative 1.1. It's downhill, right? We're going down toward the intersection low point. What about this long stretch from here to here? Right? The slope from this point that we just designed all the way to this point. It's going to have minimum slope. Right? That length is going to have a minimum slope. Right? And that's between here and here. We're going to use negative 0.5, which gives me downhill toward the corner, down to the low point. And then in here, this is the other curve. This is the other curve. What are we going to use here? Negative 1.1. So now I have this curve has the slope on center to guarantee the gutter grade, 1.1. And now I want to have a high point right here. I want to have a high point right here. So these tangents, this tangent and this tangent, and let me show you what that is in the plan view. Right? I just designed this one here. Right? From here, we're going up at 1.1, which is a negative 1.1% slope. And now I want to go from here to here up at 2%. I want that to be a high point. And then from there, I want to go down at 0.5%. Right? So from here, I want to go to here, up at 0.5%. And from here to here, I want to go down at 0.5%. I want this location to be a high point. So let's go back to the profile. Right? I want this point to be the high point. Right? So what am I going to type in for this slope here? What's the slope of this line? Minimum grade. What should I type in here? Yep, negative 0.5. There's the high point, and then this one should be positive 0.5. And I've just designed the high point on the road. Okay, so you can see 40, 190, 140. The high point is right here. Okay, and now look at your change in slope. Okay, change in slope. 1.5, 1, 0.6, 0.6, 0.6, 0.6, 1, all the way up to here. None of these, except the first one, are bigger than 1%. And remember, if there's a grade change of more than 1%, you need a vertical curve. The only exception to that rule is at the intersection. Right? When you're going from the pavement, this is 2%, and this is 0.5%. Right here, technically, you need a vertical curve, but that's the one exception. The maximum grade change here is 1.5. That's allowed without a vertical curve. Okay, and that's what they did on Chugach at the beginning. Right? Down at 2%, down at 0.5%. Right here, this PVI, and it's right here. You'll see the PVI is sorry, where is it? Right, where's 0? Sorry, right. So that's the beginning. Sorry, wrong one. Go back to here. This one. Geometry. Here's my panorama. There we go. So you'll see here, -2, -0.5. They broke the rule here as well. That's at the beginning of the alignment. That's right here, right? So at the intersection, to get from the pavement down to the low point, they allow right here a grade change of 1.5%. But everywhere else, you can't go more than 1%, right? So now we've designed it in plan. I'll show you in plan the extent. We've designed from here to the low point, up 0.5% to here. Then from there, we started designing Street B, down to the low point, around the bend, all the way to here, around this bend, up to the high point, and down to a low point. I'm going to stop there right now. Okay. On this side, I've got the design from the previous Chugach, right? The profile of Chugach up to here. So now I need to design between this point and this point, keeping in mind where the intersection is. Okay, so let's look at that in the profile. So here's the high point that we just designed. So this is the last thing I designed right here. All right, I'm just going to draw a vertical line here. There's the last thing I designed, right? Not the high point, but starting to come down from the high point. So that's fixed. Everything from there to there is done. The original design started at the intersection and went all the way to this point here. So this is fixed. Right? So from here to here is the original design. I'm not changing it. From here to here, I just designed it. So I'm not changing that now. And now I need to design between here and here, which in the plan view is from this elbow to this elbow. I need to design between the two elbows, keeping in mind I have this intersection. So in the intersection, I want to design, I want to know where this low point is, and I want to know where this intersection point is. So I'm going to project these 2 points to the profile because they're key stations. Okay. I don't want my low point at the crown intersections, right? This is the alignment, this is the alignment. Okay. I don't want my low point there. I want my low point to be at the projection of one of the gutters, right? So this is actually in line with the gutter, right? It's just extended. I could put it here, or I could put it here. Right? The low point could be here or here, but not here. Okay? Never put it on the crown of the two roads. Put it on the projection of one of the gutters. Okay? It works out, this one works out better. Okay, so I want you to put it here. So I need to project this so I can design that as a low point location, and then I need to interpolate this value, because when I'm done designing street B, I then need to take the elevation of this road profile at this location and project it to this location, this profile, right? This is a common elevation to both. So let's project these 2 points. Save my drawing before I lose it. So now I'm going to go to project the points. I want the low point and I want the intersection point. The low point is critical to the design. This is just interpolating. Okay, so I'm going to put them here, and they should lie between these 2 lines, somewhere in here. Project them to the surface so that they don't get out of range. And this is the low point, and this is the intersection. Okay. All right. So this is a high point right here. That's the high point. And I want to put another high point here somewhere, right? Somewhere over here. I'm not sure which side it's going to be on. It's probably this side. And then on the other side, somewhere right here, exactly here is where my low point is. Right? So I have a high point, and then the low point for where street A goes down and away. Okay, so I've got this high point. I want to design from the high point down to the low point, and I want to push the low point down as much as possible. Okay, I want to push it down as much as possible. So the minimum length of a tangent is 10 meters, and that's what I used here. Okay? I'm going to use a 10-meter minimum. So when you create a slope, you have to carry it for at least 10 meters. Okay? You don't want to change slope every 1 or 2 meters. You want to go at least 10 meters horizontally. Okay, so what I want to do is I want to come down as much as possible, and again, I want to avoid using vertical curves. Okay, so in this area here between the high point and the low point, I want to do this. Okay, again, I want to avoid using vertical curves. So let me just draw this here. I'm going to show you schematically, and then I'll show you how to do it digitally. Here's the low point location. Here's the high point location. Right, so that's the distance between the high point and the low point. Okay. From the high point, I want to come down 0.5% for 10 meters, and from the low point, I want to go up at 0.5% for 10 meters. Okay, and what I'd like to do, I'm going to trace it. So from here to here, there's the angle that represents 0.5%. So I'm going to put it here. Then I'm going to take that, I'm going to make a copy of that from here, and I'm going to put it here. Okay. Now, if I was to extend this all the way to here, right? If I was to extend this all the way here, there's the low point elevation, right? From here down at 0.5% all the way to the low point station. Okay. But I can do better than that. I can go 0.5% down, and then I can go steeper and then flatten out again, right? So 0.5%, 0.5%, these are both down toward the low point, right? What slope should I put here to avoid vertical curves? Right? If the difference in slope between these two is more than 1%, that's no good. If between here and here I have more than 1%, that's no good. So if this is down at 0.5%, this from here to here could be maximum 1.5%. Very good, right? So then the grade change between 1.5 and 0.5 is 1, and the grade change between 0.5 and 1.5 is also 1. So I have to put this so that I have a 1.5% grade, 1.5% grade between this point and this point. Everybody agree with that solution? That's the lowest I can get, right? I'm fixed here. I've already designed this. That's not going to change. But if I make this 1.5 and I make this 0.5, then that'll be the elevation of the low point. Everybody agree with that? So now I need one more station. I need to know the station of this point here. This point here. Well, it's 10 meters away, offset 10 meters. It's over here. That's the station. So if I come back up here, I need a PVI at the low point, and I need a PVI 10 meters away. These are the station values. So I'm going to add. I'm going to start over here. I'm going to click on the design, right click, and I'm going to go to the edit the geometry. And then I'm going to add two more PVIs. The low point, node, and then this point here 10 meters away. This is exactly 10 meters because I offset this line. So there's 10 meters. So now I'm going to go back to my profile, my panorama, right? I'm going to find this value, which is at station 340, 330. Right, so I'm going to find 340, 330. So there it is. So this is this slope here. And then this is the positive slope coming up to the high point, which is this one. So now this slope here that's labeled 2.72 needs to be what? What should this be? And it's going to be positive, right? In the direction of chainage, it's going to be positive, 1.5, right? Up to the high point. And then this one, the next one needs to be up from the low point. What's the slope going to be? Positive 0.5. So now I've designed the elevation of the low point, right? And then I need to interpolate this elevation for street A. We'll do that later. Okay, let's finish the design of street B. Any questions about that? What we just did? Right? So I'm avoiding vertical curves by using the minimum length with the minimum slope at the low point and the minimum length and the minimum slope at the high point. And then I'm transitioning in between a difference of maximum 1%, right? 0.5 subtract 1.5 is 1. 1.5 subtract 0.5 is also 1%. So the A value here is 1 and the A value here is 1, a grade change of 1%. Okay. If I go any lower, if I make this any steeper, I'm going to need a vertical curve here and I'm going to need a vertical curve here, which I want to avoid. Okay. We'll worry about interpolating later. So now I've designed from here all the way to here. And there's another point here, 10 meters away, right? So if you want to draw a circle here, 10 meters, I've actually designed the PVI right there as well, right? But not in the plan, I did it in the profile. And the reason I was able to offset 10 meters in the profile is because this is a straight line. Okay, otherwise you'd have to measure along a curved road 10 meters away. Okay, but you can do it in the profile very easily, right? So I took that position and I offset in the profile 10 meters. This will interpolate later. Okay, we'll get to that. Okay, now I need to design between the end of this profile and the low point. the end of this profile and the low point. Okay, so let's go back to the profile. So we're done with this. So here now, leading down to the low point, I want to use another 10 meters. Coming down at 0.5%. So 10 meters away from here, right, I want to go 0.5%. Okay? Now it doesn't have to be a minimum of 10, but I'm going to start with that, right? So I'm going to do this. I'm going to offset 10 meters a point. Whoops, can't offset that. I'm going to offset a point. I'm going to retrace this from here to here. Offset 10 meters. So 10 meters away minimum is where my PVI is going to be coming down at 0.5%, right? So I'm going to add another PVI at this location, right? So take my design, go to the geometry, add a PVI. I'm going to put it right here. Oops, put it here. Okay. So now I've got this leading into the low point. Go back to my panorama. I'm going to make that slope negative 0.5. So that 319 becomes negative 0.5. Okay, so now I'm coming down to the low point. Right? So from the low point, I'm coming up. From the previous design, I'm coming up. So those two lines are going to intersect somewhere and give me another high point. Okay. So let's try this. I'm going to trace. I'm doing this with AutoCAD lines. I'm going to draw a line from this end point to this end point. Now I've traced the 1.5% grade. Then on this side, I'm going to trace this 0.5% grade. I'm going to draw a line from the low point to this 10 meters away, and now I've got 0.5%. And now I'm going to fill it with a radius of 0. I want to find where this line intersects this line. Everybody see that? That's where the two lines intersect. The slope of this line is 1.5. Is it positive or negative? Is it positive or negative? It's positive. The slope of this line, is 0.5%. Is it positive or negative? It's negative. So what's the algebraic difference between this slope, 1.5, and this slope, negative 0.5? What's the A value here? What's the G1 minus G2? Anybody else? Yeah, it's 2%. Positive 1.5 subtract negative 0.5 is 2%. So technically, I need a vertical curve here. Everybody agree? If you're coming up at 1.5 and then you're going down at 0.5%, the change in slope is -2 or 2%. So now this PVI needs a vertical curve. Everybody agree with that statement? Everybody agree with that? Okay. I don't want to use a vertical curve. So here's a practical way of avoiding a vertical curve. I'm going to make a copy. I'm going to make a copy of this 1.5 and this negative 0.5. Right? There's the PVI that has a 2% grade change. I'm going to bring it down here. Okay? I'm going to move it apart. And I want to draw between here and here, right? Between here and here, I want to draw a transition. I want to go from positive 1.5. What's 1.5 subtract 1? 0.5. What's positive 0.5 subtract negative 0.5? So if I put in between here and here, if I put in something that's minimum length, 10 meters, with a positive 0.5% slope, then I'll have not one but two PVIs where each one has a grade change of 1%. I'm going to go from 1.5 to positive 0.5, grade change of 1%, and then I'm going to change it the next one by 1% from positive 0.5 to negative 0.5, another PVI with a 1% grade change. So I'm going to go from one PVI with a grade change of 2 to two PVIs with a grade change of 1. And then I can avoid a vertical curve. Okay? So here's what I'm going to do. This is 1.5%. I traced it. Remember, I traced it. I connected the dots between these two PVIs, so that's 1.5%. positive. This is negative 0.5%. I traced it over here, right? I traced it between these two PVIs. So if this is positive 1.5, this is negative 1.5. Sorry, positive 1.5, negative 0.5. I'm going to mirror this. Now, if this is negative, then this is positive. Negative 0.5, positive 0.5. And then I'm going to go over here. I'm going to draw a line from here, 10 meters horizontal. And I'm going to go up and I'm going to trim it. So this is positive 0.5 with a horizontal distance of 10 meters. And I want to put that in here. I want to splice it in here, right? So then I go from positive 1.5 to positive 0.5, grade change of 1%, positive 0.5 to negative 0.5, 1% grade change. So this is what I'm going to do. I'm going to move this line so that it ends here, and I'm going to move this line so that it starts here. And that's what the profile needs to look like. 1.5% positive, take away 1%, 0.5% positive. Take away 0.5%, negative 0.5%. Positive 0.5, negative 0.5, a 1% grade change. 1.5 positive to 0.5% positive, a 1% grade change. So this is what the design should look like if I want to avoid the vertical curves. Okay, any questions about that? Now, because I drafted the solution right there, I'm going to borrow the information I just drew. Watch this. I'm going to take a fillet with a radius of 0. I want the 1.5 to intersect the negative 0.5. And now this point is where the PVI is that has a 2% grade change, right? 1.5 positive, 0.5% negative, 1%, a 2% grade change. And now I'm going to move this piece with this reference point to the same point in the profile. And now I've designed the two PVIs, this one and this one, that has the 1% grade change. Okay, so now I can just add two more PVIs, the beginning of this and the end of this 10-meter piece. Okay, so I go back to my design, so go back to here, right click, geometry, add two more PVIs. I'm going to add a PVI here, I'm going to add a PVI here. Okay, and now if you want to be able to read this, right, positive 1.5, I'm just extending this from here, the last designed point. I'm going to extend that in my design, 1.5%. So even though this is not 10 meters, it's really 23 plus 7, right? 23 plus 6, right? The 1.5% starts here and goes to this point and beyond. So really we don't need this PVI, but I'm going to leave it because it's the last design point from the previous design. Okay, so it's redundant, but I'm going to leave it for reference. Okay, so don't be discouraged by the fact that this is less than 10%. It's really this plus this that is at 1.5%, right? So this is redundant. You don't really need this, but we're going to keep it. So I'm going from 1.5% positive to 0.5% positive, a grade change of 1%. And then I'm going from positive 0.5 to negative 0.5. There's a 1% grade change here. And now I'm going all the way down to the low point. We really don't need this one. Right? Down 0.5%, down 0.5%. I can delete this PVI. It's part of my design. It doesn't need to be 10 meters. I can go from here all the way down to the low point. So this one I'm going to delete it. How do you delete a PVI? This next button here. Whatever you're closest to will disappear. Right? So I just combine those two because they both have the same slope. Okay? I'm going to do it here, but not over here. These two have the same slope. This point is of interest because it's the end of the existing design, and then from there forward we're adding to it. So it's convenient to know that information. Really you don't need it, but we're going to keep it. And that's the design of the profile. I can get rid of all my construction lines, everything I drew, right? All this stuff here. And now I have a high point, and a low point at the location of the projected gutter line to the center line. And that's the design of the profile for Street B. We're almost done. We're running out of time. We're almost done. Let me get it in so that we're complete. I want to now project the elevation of the design at the intersection. And I don't need it in the profile. I could just do what I did before. Watch. I want to know the elevation of this point from this design, bring it to the plan view, and then project it to this profile. Okay, how do we do that? Well, that's that new tool I taught you today. So we're going to look at, where is it? Points, create points. We're going to use this one here, station offset. From this design, from this profile design, street B, the FG, I should have renamed that, FG, sorry. And I want to put it right here, node, and 0 offset, enter. And that's the design elevation there. Now let's check it, right? It should be a little bit higher than this elevation in the profile, right? So this is 659. And the low point is here. 637, this is 659, a little bit higher, right? And less than this, 687, right? So 657 makes sense. If you want it explicitly, you can add a PVI there, right? You can do this. You go to geometry, you can add a PVI exactly here at this intersection. That'll interpolate. And then if you don't see the label for the PVI, you can change the frequency on the profile, which is the style for the label. So if you go to edit labels, there's a thing here called weeding. Change the weeding to 0. And then it shows all the labels. There you go. So see the 659? That's what I projected to the plan. 659. Now I'm going to project that to the profile of street A, tool we learned last year. Take that point and bring it to street A at the end of street A, or at the end of street A, right? Leave the elevation, that's what you want. And there's the crown of the road. Okay? And now we want to know where the edge of pavement is. So I want to know what the point is again, right? This is the projected gutter, right? Offset the center line 4.3. That's how I found this point. I'm going to project that point to the plan, to the profile for reference. It doesn't have an elevation, so I need to bring it to the elevation of the existing ground. Again, it's the station I'm interested in. Whoops, station I'm interested in. And there's the station. So now, again, I'm not going to create a new one. I want to extend this one. I want to extend this all the way to here, and I want to come down. What's the slope from here to here going to be? Right, from here to here. Let me add the PVIs. So I want to go from, whoops, wrong one, street A, geometry. I'm going to add a PVI here, and I'm going to add a PVI here. All right, so what should the slope of this be? Now I'm working from the end, so I want to start here. What should the slope be? Remember, it's the pavement coming down from the crown, but working in the direction of increasing chainage. Positive 2%. Okay? So now you'll see this is 4.6%, right? It wants to be 0.5% minimum, right? 0.5% minimum. But if I make this 0.5%, so now I work in the direction of chainage, right? If I make that one, now I'm in the grayed out column. If I make that 0.5%, now the crown is going to be compromised, right? So now, technically, I need to raise this elevation, which means raise the elevation in the other profile. So this is what I mean about iterative, right? I've done something in the other road, and now I'm trying to use it on this road, and it's not working. Right? Really, I need to use the 0.5% grade. I can't go flatter. And when I get to the edge of pavement, I need to go up at 0.5%. So I want this to be 0.5% at the end. Grade out. I want to change the crown, positive 2%. The design needs to be up here, not down here. So my low point on the other road is too low for my minimum slope to work on street A. So now I got to go back and fix street A. I have to raise the elevation from this design up to here to match this. So now I go backwards. So this is no good. Now I project this design elevation back to the plan and then take it to the other profile. And this is the iterative nature of the design, okay? Because I'm using slope, right? Up at 0.5%, up at 2%. This cannot be any lower. Otherwise, I won't have a crown at 2% and I won't have a minimum slope of 0.5%, right? If I go back, bring that point back, right? If I put this back here, right? If I put this back here, I can't do this. I can't go lower, right? Because then if I flatten this out, if I make that 2% again, right? -2 or +2, push that down. Now this is too flat, right? And if I push this down, it's going to push all of it down, right? I can't go lower. I'm starting here at minimum grade and I'm working my way up. So now I need to, again, I did something on street B. It's not working on street A. So now I got to go kind of reverse engineer what's happening on street B. Right, so I'm going to start here. So now I'm going to design street A. I'm going to finish designing street A. So it's going to be 0.5%, up at 0.5%, up at 2%, and now I have to match that on the other road. We can use 1% for the first 20 meters. Sorry, 1% where? First 20 meters of street A, here. Trong. You want to use 1% here? Where's the 1%? So you're going to create a high point here, like this. You want to create a high point? Okay, I'd have to see your solution. I don't think it works. This is the minimum. You can't go lower than this on this road. I'd have to see your solution. I'd like to see a sketch of what you're talking about, right? If we're using minimum grade, right, I'm coming down at 2% to match. I'm coming down at the minimum 0.5%. I need a low point. And then I'm going up at 0.5% all the way to the edge of pavement. And then I have to go up 2% because that's the crossfall of the road, right? So now I need this design elevation in the other profile. So then you use the tool I showed you today, right? And really, I've gone over time. Sorry to keep you all. I'll finish this lesson next week. See if you can figure it out, right? I'll pick up where we left off now. But see if you can design street A and street B, even though it's wrong, it's not going to work. I'm going to have to raise the low point to match. And what's that going to do? When I raise the low point, it's going to, well, there's a couple of options here. Okay, so you guys can try it, but it's not going to work. Okay, so give it a try. And again, I'm not doing this to encourage you or to make you mad or to make you do extra work. It's practice on the type of thing you're going to encounter. Okay, so now I'm stuck. I got to go back and fix this road to match, right? So it's kind of chicken and egg. You have to design one and then let the other one match. And if that doesn't work, you have to design that one and go back and see if the first one will match. And you won't know which one to do first until you try one. It's kind of a cyclic thing. You have to jump in, do something, see if it works for the other one. It doesn't, okay, try something else. And it's a little bit back and forth, okay? So in this particular example, I should have designed street A first. And then I would have had the elevation of the low point I needed. And then I could have designed the rest of street B. Right? But I didn't know that going forward. I had to start with one and then hope the other one worked and vice versa. All right. So see if you can at least do what I did for next week as a minimum. Okay. If you want, you can create the corridor, add street A, add street B to the corridor model. The other thing you have to do, which I haven't covered yet, is you have to update the elbow. Remember, you need to split the region, create an alignment along the gutter line, right? So review the corridor model that you did in Richmond Hill last semester. We still have to do that. And then we'll get to the grading, okay? So that's plenty of work for next week. At the very least, see if you can get to the same point that I left off at, right? And then I'll redesign street B to match street A, and then we'll get into the elbows, all right? So pay attention to your email tonight. I'll be sending out the results of assignment 1 or submission 1. Okay, sorry to keep you late. I know I've gone overtime, but I'll see you next week. Any questions, email me and I'll set up a meeting. All right, and that's it for today. Sorry to keep you so late. You're welcome. Thank you for attending. You're welcome.